Good morning all. Welcome to my channel Vijay Physics Sprint. Today we'll discuss about electrostatics. So electrostatics is very important for Jee Mians and as well as Neet, right? So what do you mean by the electrostatics? Electrostatics is nothing but is a branch of physics which studies about charges which are at rest. So the branch of physics which studies about charge which are at rest, it is known as electrostatics. If the same charges in motion, if charges are in motion, then that is called as current electricity. Current electricity is a branch of physics studies about same charges but at motion. In motion, that is called as current electricity. If the same charge is at rest, that is called as electrostatics. Okay. So charges. How many types of charges we have? So mainly we have two types of charges. I think you know about these charges: positive charges and negative charges. Positively charged body, negatively charged body. Negative charge. So when will get positive charged body and when will get negative charged body? If the body lost some electrons, if the neutral body lost some electrons, so loss of electrons, then the body gains positive charge. Positively charged body. If electrons are going to be lost, then its weight. What about this weight? Weight is going to be decreases. Weight it is decreases for positive charged body. If it is negative charged body means if gains some electrons, then it acquires negatively charged body, then its weight going to be increases. So positively charged body, loss of electrons, weight is decreases. Negatively charged body, gain of some electrons, weight is going to be increases. If it is neutral body, what do you mean by the neutral? Neutral means having positive and negative both charges but equal number of charges, then it is known as neutral charged body. So positive charged body, negatively charged body, neutral charged body. So loss of electrons, weight is decreases for positive. Gain of electrons, weight is increases for negative charged body. And charges has some properties. So mainly charges has three properties: additive property, conservation of charge, and quantization of charge. Additive property of charges is the first property. Additive property of charges. Second, it is conservation of charge. Third, it is quantization of charge. So what do you mean by the additive property of the charges? For example, on the body, different charges are given: Q1 minus Q2, Q3, Q4, Q5. Different charges are given: minus Q2, minus Q4 and minus Q5. Then what is the total charge on the body? Total charge means take the sum of all individual charges. All individual charges mean Q1. Second it is minus Q2. Third it is Q3 plus fourth one it is minus Q4 and this is minus Q5. So algebraic sum of individual charges gives total charge on the system or on the body. So same equation can be written as Q net equal to sigma Qi, I is equals to 1 to n. This is for additive property. Sum of the individual charges gives total charge on the system. Now conservation of charge. It is analogous to conservation of energy. What is conservation of energy? Energy neither created nor destroyed. Similar way, conservation of charge. Conservation of charge means loss of electrons, it is gain of electrons. For example, these two bolts are contact. Then what happens? Charges transfer from one body to other body, but total amount of charge remains constant. Total amount of charge remains constant. Charge neither be created nor be destroyed, but transferred from one body to other body. Total amount of charge remains constant. That is called as conservation of charge. Now very important is quantization of charge. What do you mean by the quantization of charge? The total charge Q can be written as integral multiples of charge of electron. N is an integer, E is a charge of electron. What do you mean by the charge of electron? It is 1.6 into 10 power of minus 19 coulombs. Coulombs is a unit of charge. Coulomb is a unit of charge. Dimensional formula of the charge, it is IT or AT. Is a dimensional formula of charge. Unit is coulomb. Dimensional formula is IT or AT. Charge of electron or proton 1.6 10 power of minus 19. Total charge on system Q equal to plus or minus. Plus for positive charged body and minus for negatively charged body. So total charge on the system can be written as integral multiples of charge of electron. N is an integer, so the value of N is becomes 1, 2, 3, 4 up to so on. So this is for quantization of charge, additive property, conservation of charge. Three properties of the charges. Total charge is equals to individual sum of the individual charges. Charge neither be created nor be destroyed, but transferred from one body to other body. Total amount of charge remains constant. And third, the total charge is equals to integral multiples of charge of electron. This is third property of the charge. Now we'll discuss about Coulomb's inverse square law. The very important concept in electrostatics, the basic thing, Coulomb's inverse square law. So what is Coulomb's inverse square law? Coulomb's inverse square law gives the derivation of electrostatic force. Coulomb's inverse square law. So now the next one is Coulomb's inverse square law. So what is Coulomb inverse square law? For example, two charges Q1 and Q2. These two charges may be like charges or unlike charges. If it is like, means both are positive or both are negative. Like charges, then in between these two, repulsion force will act. Which force it is? Repulsion. If these two charges are unlike, means one is positive, one is negative. Like unlike charges, then attraction force will act. So the force of attraction or repulsion, simply I am writing as electrostatic force, F. This electrostatic force depends upon three factors. Number one, directly proportional to product of charges Q1, Q2, and R is a distance, inversely proportional to square of the distance. Depends upon three factors. One, product of charges, it is directly proportional. Square of distance, inversely proportional. Third, its surrounding medium. If it is medium, is free space, then what happens? If the medium is other than free space, then what happens? Before that, combine these two equations, F proportional to Q1 Q2 by R square. Then F is equals to K Q1 Q2 by R square. What is K? Is a proportionality constant. So here the value of K in the free space. What do you mean by the free space? Air or vacuum known as free space. The value of K is 1 by 4 pi epsilon naught. What is epsilon naught? It is permittivity. What do you mean by the permittivity of free space? Free space. Permittivity means if place the charge in the medium, due to the medium, how the charge is going to be affected. Due to the medium, it may be air, vacuum, whatever it may be. Due to the medium, if charge is going to be affected, how much of the charge is going to be affected by the medium, it is called as permittivity. So permittivity of free space, epsilon naught. You have to remember this value. Epsilon naught value 8.85, 10 power of minus 12. Coulomb square per Newton meter square epsilon naught value. So K value becomes 1 by 4, pi value 22 by 7, epsilon naught 8.85 10 power of minus 12. But in the numericals, in place of 1 by 4 pi epsilon naught, simply you can substitute 9 into 10 power 9. So 9 into 10 power 9, Q1 Q2 by R squared. That's all. You will get easy equation. So F is equals to K 1 by 4 pi epsilon naught Q1 Q2 by R square. It is in the medium free space. Other than free space, so other than free space, then the value of K becomes 1 by 4 pi epsilon. Then substitute here, then F is equals to 1 by 4 pi epsilon Q1 Q2 by R square. This is other than free space, like a glass, like a water. Then in that medium, the value of force of attraction or repulsion 1 by 4 pi epsilon Q1 Q2 by R square. In the free space, other than free space. In vector representation, sometimes asking in vector representation. So Q1 first charge, Q2 second charge. So force of attraction F12, distance is R12, then F12 written as in vector representation. K 1 by 4 pi epsilon naught Q1 Q2 by R square, right? It is R1 square into R12 bar. So is a vector representation. F12 is equal to K Q1 Q2 by, so this is R1 Q12 and R12 bar, right? It's a vector representation. Now some properties of this electrostatic force. See the properties of this electrostatic force. Force 1 by 4 pi epsilon naught Q1 Q2 by R square. The force of attraction or repulsion depends upon square of the distance. That is the reason it is known as inverse square law. So the force depends upon square of distance. If the force depends upon square of distance, the type of force is known as central force. Central force depends upon the distance. And so Coulomb inverse square law is a central force. Coulomb inverse square law is a conservative force. What do you mean by the conservative? Already discussed in work energy power. If the total work done in closed path, then the force is called as conservative force, independent on the path. So conservative. And the stronger this force is stronger than gravitational force. We know 4 basic forces: gravitational, electromagnetic, strong nuclear, weak nuclear. So this electrostatic force is stronger than gravitational force. How many times? Electrostatic force 10 power 36 times of gravitational force. Next, F proportional to Q1 Q2. Okay, so F2 by F1 becomes Q1 dash Q2 dash by Q1 Q2. F proportional to 1 by R square. So F2 by F1 equal to R1 by R2 whole square, right? One more point. Depends upon the medium. So dielectric constant, just now we wrote epsilon by epsilon naught. So epsilon naught becomes epsilon by K. Substitute here. So F is equals to 1 by 4 pi epsilon naught. Epsilon, of course, this is K. Q1 Q2 by R square. If the charges are separated some distance R, then force of attraction F. If medium is different and distance is also different, but same force, same charges, then K into R square equal to constant. Is one more property. This is number 6. Okay. So these are the main properties of Coulomb inverse square law. Coulomb force is a central force and conservative force, stronger than gravitational force, and F proportional to Q1, Q2, proportional to 1 by R square, and K into R square equal to constant. K is a dielectric constant of the medium. Okay, see one more model of the problem. So two spheres having charges Q1 and Q2 separated by some certain distance. First sphere Q1, second sphere charge Q2. Remember, charges always lies on the surface of the body. Right? Q1 on surface of the first sphere, Q2 is a charge on the second sphere separated by distance of R. Now the force of attraction is F. Okay. Now these spheres are brought in contact and separated by same distance. Then force of attraction is F dash. Now calculate what is the ratio of F dash to F. Right? See here, calculating the ratio of F dash by F. Before contact, what is the charges Q1, Q2? Distance is R. Then force of attraction is 1 by 4 pi epsilon naught Q1, Q2 by R square. When brought into contact, what happens? For example, Q1 is greater than Q2, then charges are transferred from first sphere to second sphere till getting the equal number of charges. Equal number nothing but taking the average. Q1 plus Q2 by 2, first sphere, second sphere also same charge. So Q1 dash becomes Q1 plus Q2 by 2. Q2 dash also Q1 plus Q2 by 2. Now F dash, F is equals to same 1 by 4 pi epsilon naught, simply it is K, right? Q1, the first charge, Q1 plus Q2 by 2. Second Q1 plus Q2 by 2, same distance by R square. So F dash becomes, what is F dash? F dash is equals to Q1 plus Q2 whole square by 4 R square. Now taking the ratio F dash by F, K is cancelled, R square is cancelled, then remaining Q1 plus Q2 whole square by 4 Q1 Q2. So this is the ratio of the charges after contacting the sphere to the before, means before contacting the spheres, F dash by F value. So one more method of this, one more model of the problem, and one more method, multiple charges. If two charges are there, simply Q1 Q2 by R square. If it is more than 2, for example, Q1 one charge, Q2, Q3, Q4, then what is the total charge on Q1? Then you can take vector addition of the forces. For example, in between these two, the force is F1. In between these two, force is F2. In between these two charges, force is F3. Now take sum of all force vectors. So F1 bar, F2 bar, F3 bar. Total force F can be written as F1 bar plus F2 bar plus F3 bar. So this is the force due to multiple charges. Total force can be written as sum of the vectors. So sum of force vectors you can take F bar equal to F1 bar plus F2 bar plus F3 bar. So this is force in between among the multiple charges. Okay. So if you have any doubts, you can make the question comment box. So please like, subscribe, share my channel, these videos. Thank you all.